Okay, so welcome back to another video. So here today we want to solve for the real solutions of our given, and that is to find x such that 1 over x minus 25 plus 1 over x minus 26 plus 1 over x minus 27 plus 1 over x minus 28 is equal to 0. Now you can actually do this how you're taught in a typical algebra course, elementary level, that you can actually just, get a common denominator and then multiply your numerators with the with those binomial factors, cancels those out, and eventually as you approach with those techniques, the algebraic techniques, that you actually get yourself in the form of a cubic polynomial to solve for that solution. But that's going to make things a little more difficult, and you're going to be sitting here for a long time trying to find those solutions. Instead, we're going to take this into a more shortcut, and I guess the word hard is applicable more in the sense of saying that this is not really the technique that you're typically taught in school, but this is the more, you have to be a little creative in this situation. So that's actually the demonstration of how we're going to do for today's video, in a sense that we're just going to let one of the parameters equal this, and then another parameter equals that, set that into our equation, and then solve from there. And it actually comes out there, our solutions are actually going to come out a little bit easier to solve for. So let's actually just jump right in. So suppose that if we let a equals x minus 26, and then also if we let our second parameter variable b equals x minus 27, then if we just plug this all back into our given equation, so we would have the following. So I can plug a plus 1 for here, that's going to match with the 1 over x minus 25. Add this with 1 divided by b plus 1 coming from here, that's how we get our 26. Add this with 1 divided by a minus 1, and the same thing. So then over here will be 1 divided by b minus 1. Set that equal to 0. And then everything is in terms with addition, so it's commutative. So I'm actually going to rearrange the terms, and then afterwards I'm actually going to set a common denominator. But for that to work, I'm actually going to group this with the same letters. So a plus 1 and a minus 1 is going to be a denominator on its own, and then b plus 1 and b minus 1 is a denominator on its own as well. And then applying that cross multiply, so we have a minus 1. Add this with a plus 1, then of course this is a plus 1 times a subtract 1. And if we just do the same thing for the b term, so it's just b subtract 1, add this with b plus 1, and then all this being divided by b plus 1, and then multiply with b minus 1, and then that's still equal to 0. And then simply what we can do, as we see here, if we just simplify this out, we actually get everything in terms of the denominator is basically just difference of squares for both of them, and then you just add terms together. So we have a 2a, then we divide this by a squared minus 1, add this with 2b, and then divided by b squared minus 1, set that equal to 0. And now further continuing, we can actually do a common denominator yet again a second time, and then we just multiply both sides and get 0, but then you do the cross multiply, and so now we're not dealing with rational functions in this situation now. So we have 2a multiplied by b squared subtract 1, then add this with 2b multiplied by a squared subtract 1 equals 0. And then further ahead, if I can just simplify a little further, so after performing all this distributive method, so we have 2ab squared minus 2a, add this with 2a squared b, then minus 2b is equal to 0. Then I can actually just factor out we can factor out the 2ab from these terms and factor out a 2. So we have 2ab, then we multiply by a plus b, then subtract 2, then a plus b, and then this is just equal to 0. Divide the 2 to both sides, and then that'll just make things a little bit simpler from here. So now we have ab multiplied by a plus b, then subtract a plus b, and then you'll notice that both of these terms actually contain an a plus b, so we can actually factor the a plus b out, and now we actually get ourselves a little binomial right here. So a plus b, And then now we multiply by a times b and then subtract 1 equals 0. So now this makes things a little bit easier. Now we just have to solve each of these binomials for 0. So let me start with a plus b. A plus b is equal to 0, and then a times b subtract 1 is equal to 0. So let's start off with the first equation, which is a little bit more easier because we define what a and b are equal to in this situation of the substitution. So by doing so, we just plug in everything. So that means we have, we said a is x minus 26. Then we add this with, we said b is x minus 27. If you solve this out, so we have 2x and then minus 26 plus minus 27, so minus 53 equals 0. Add the 53 to both sides, so 2x equals 53. Divide 2 to both sides, and so we have x is equal to 53 divided by 2. And so we found our first solution. We're not done yet because we still have to figure out our solutions for this equation over here. So let me box this first to say that we found our real solution for this equation over here. So now let's actually move on to the second one. So now over here, if you want to notice something, pay attention that a minus b, if we actually just substitute this, so x minus 26 and then subtract x minus 27, then we see that the x just cancels. So minus 26 at that is equal to 1. So we say that 1 is equal to a minus b. We can do a little bit of a substitution. We can solve for one of the variables. Let's say we solve for just for a on its own. So that means I just add b to both sides. So a is equal to b plus 1. Okay, then if by doing so, we can actually plug our substitution for a back into this equation. So we have b plus 1, then multiplied by b, and it's equal to 0. Just do some distributing. So b squared, I forgot the minus 1 over here. So minus 1 and then equals 0. All right, it's a little better. B squared, then plus b, and then minus 1. Minus 1 is equal to 0. Then you solve for your b. Obviously, it's impossible to do this like by, in terms of, factoring. So we had to actually use the quadratic formula. And so we say that b is equal to, plug in your b, a, and c terms. So I have negative 1 plus or minus the square root of 1 squared, subtract 4 times 1, then times negative 1, and all this being divided by 2a, which is just 2. This is going to give us negative 1 plus or minus the square root of 5, and then plus or minus the square root of 5. And then we set this equal to b. So in other words, our b, we set that it was x minus 27. And then if you just solve, you're going to get two different solutions with the plus and minus. So that means x is equal to plus 27, then get a, same denominator. So that'll be plus 54 on the numerator, and then add that. So now we have 53 plus or minus the square root of 5 divided by 2. And so just like that, we actually have 3 solutions we have found. We found that x can equal 53 over 2. We found out that x can equal 53 plus square root of 5 divided by 2. And we also have x is equal to 53 subtract the square root of 5 divided by 2. And so just like that, we actually found our solutions. The quicker method, and again, you can actually do the same thing as I mentioned, get this into a, eventually you'll get this into a cubic polynomial and then solve for your x's from there, but that's actually kind of the longer method. It's, you're just wasting, I don't like to say it like that. You can go ahead and try, but I'm just saying you're just wasting time, assuming if you were asked a question like this on a test to, solve it in that sort of method. It's easier to actually do it with this approach, assuming that if it's a similar form like this, for example. So yeah, that's pretty cool if you ask me.